Hello everyone, I'm Mehmet Kerimücel, and I'm pleased to present HybridAugment++, Unified Frequency Spectra Perturbations for Model Robustness, which is a joint work between Hacettepe University and Middle East Technical University. Last decade has shown that CNNs are accurate across different tasks and different modalities, but they tend to fail under distribution shifts. The goal of our paper is simple. We want to achieve robust and accurate CNNs. From a frequency perspective, assuming image classification, the literature tells us that CNNs tend to favor high-frequency content of the data. Similarly, they overly rely on the amplitude component of the data. In contrast, images are dominated with low-frequency content, and us humans tend to favor phase component of the data. Taking robustness accuracy trade-off from a frequency perspective, we can see that focusing on high or low frequency, or amplitude or phase components give us either robust or accurate models. The question we want to answer is simple. Can we achieve the best of two worlds? In this paper, our hypothesis is that we should not rule out reliance on high frequency or amplitude, but reduce and try to control it. In other words, our aim is to make the model more reliant on low frequency or phase of low frequency of the data. We do so by proposing two augmentation methods, HybridAugment and HybridAugment++. First, inspired from the seminal hybrid images work, we propose HybridAugment, where we simply take two images in a batch and swap their high and low frequency components. The single image variant of HybridAugment does the same thing, but with two novel augmented versions of the input image. Note that single and paired versions work well together, as we will show later. We achieve good results with HybridAugment, but we want to take a step further. Our aim is to unify HybridAugment and phase amplitude reliance into a unified, effective augmentation method. HybridAugment++ does exactly that, by reducing reliance on amplitude component and high-frequency content. Here, we take three images in a batch, take the low frequency of the first, swap its amplitude with the second, and finally merge the resulting image with the high frequency of the third image. The singles variant does the same thing, but uses three novel augmented views of the input image. We now analyze the effectiveness of our methods. We first focus on corruption robustness. The results show that HybridAugment improves both accuracy and robustness compared to the standard model, which the baseline method fails to do. HybridAugment++ takes a step further and dramatically improves the robustness, while still being more accurate than the baseline. Training our methods with a higher cutoff frequency leads to more robust models, showing the flexible nature of our framework. HybridAugment++ can scale its results with more data, and works well with other augmentation methods. As shown in the Gradient visualizations, our method manages to keep its focus regardless of the corruption. Our method also outperforms adversarial training baseline in adversarial robustness, and also achieves the best clean and robust accuracy with different variants of our framework. Once scaled to ImageNet, our results are actually better, where we comfortably outperform the baselines. In out-of-distribution detection, we managed to improve over the standard model, and we are competitive against the baseline methods. We also perform experiments to assess the transfer learning performance of features learned by our method. The results show that we are visibly better than a standard model, which shows that the features learned with our method are richer and potentially more generalizable. Finally, we test our method to see if it also works on other architectures than CNNs. Our results show that our method works well with transformers too. In this paper, we propose a flexible augmentation framework that does not require extra data, models, or ensembles. Our method can be implemented in a few lines of code and improves both accuracy and robustness on various robustness benchmarks. Thanks for watching our presentation, and don't forget to visit our GitHub page for code and pre-trained models.